Okay, we've been talking about how to solve proportions. And one of the things we talked about in solving proportions is how to use proportions to find unit rates. Remember that proportions are simply ratios that are equal or equivalent to each other. In this case, we have a ratio here of 64 miles to 4 gallons. It's not only a ratio, it's also a rate. A rate. 64 miles to 4 gallons. Now we want to know if we're looking for a unit rate is something per some one of something else. So a unit rate will always have a 1 in the bottom. So it might be 20 miles per 1 gallon. That would be a unit rate. However, 20 miles per 2 gallons would not be a unit rate because it does not have a unit in the bottom. It does not have a single number, a 1, in the bottom of the fraction, in the denominator here, in the bottom of the ratio. So what we need is to find out the number of miles per 1 gallon to find the unit rate. So 64 miles is how many we get with 4 gallons. We need to know how many miles we will get with 1 gallon at the same rate. So to do that, we simply set up our proportion. 64 miles to 4 gallons is equal to X miles per 1 gallon. Then we use our cross multiplication. We multiply across the equal sign, top to bottom. And what we'll wind up with is 64 times 1, which is 64. And we wind up with 4x. 4x then is equal to 64. We know that because anytime we do cross multiplication, if the answer is proportional, the results should be equal. In this case, we know that 4x should be equal to 64. 4x is equal to 64 is just an equation, so now we're going to solve that equation. To solve that equation, we have to get x all by itself. And to do that, we use the inverse operation. The inverse of multiplication, 4 times x, is simply division. So we will divide 4 by 4. And that is going to cancel out because 4 divided by 4 is simply 1. And 1 times x is just x. Now over here, to keep our equation balanced, we have to divide by the same thing we divided by on the right side. So 64 divided by 4 is 1, and then 24 is 16. X is equal to 16. In this case, our unit rate is going to be 16 miles per 1 gallon. Per 1 gallon. Now that's how we find the unit rate. Now we are not particularly interested just in the unit rate. We want to know a unit rate to be able to compute unit rates with ratios of fractions. So we're going to take a look at this particular problem. Here we have some ratios of fractions. We know that William fills 1/3 of a water bottle in 1/6 of a minute. So we could write that out as a ratio like this. 1/3 of a bottle in 1/6 of a minute. Okay, so there's our ratio, 1/3 of a bottle in 1/6 of a minute. Now, how much time will it take him to fill the bottle? Well, notice that we have the bottle. There's only one bottle, so this is going to be a unit rate. We're going to fill the bottle, so we know that we have one bottle, and we do not know how many minutes that takes. So we'll put an X there to indicate that we don't know. This is our variable. And we know that this is going to be proportional because these have a direct relationship, and so do these. Note that if you put bottles on the top, then you have to put bottles on the top on this side as well. Bottles to bottles, minutes to minutes. They have to be the same across the top and across the bottom. Then we simply do our cross multiplication. Cross multiplication here gives us 1/3 x, 1/3 x, because we multiply 1/3 times x. Set that equal to 1/6 times 1, which is just 1/6. And then we solve our equation. So 1/3, we again want to get x all by itself, so we have to use our inverse operation. Right now we're multiplying 1/3 times x. So we need to divide 1/3 x by 1/3. 1/3 divided by 1/3 is just 1, and that leaves us with x. Then we have to keep the equation balanced, so we divide 1/6 by 1/3. 1/6 divided by 1/3, we remember that to calculate a fraction divided by a fraction, we're simply going to use our keep, change, flip method, where we keep the first. We write this again, we can write it like this, 1/6 divided by 1/3. Using keep, change, flip, we keep the first fraction in our division problem. We keep this one. We change this to multiplication, change our division to multiplication, and then we flip this fraction right here. So we wind up with 3/1. And then we can simply multiply, just like normal. Multiply across the top and across the bottom, which gives us 3/6. And we know that 3/6 can be simplified to 1/2. So x is equal to 1/2. So we know that William can fill one bottle in 1/2 a minute. So one bottle is filled in 1/2 a minute. And that is the answer to our problem. Now let's take a look at one more before we finish up. Take a look at this one. We know that Michael plays 1/5 of a song in 1/15 of a minute. Again, we have a rate here. 1/5 of a song in 1/5 of a minute. So 1/5 of a song in 1/15 of a minute. And I'm going to make sure that I write out my units, or in this case, the thing that I'm having a ratio for. 1/5 of a song to 1/15 of a minute. I'm going to set that equal to another proportional value. How much time will it take him to play an entire song? That implies it's just one song. So I'll say one song. Over here I had a fraction of a song, now I have a whole song. How long will it take him to play one entire song? How many minutes will it take him to play one entire song? And again, we're going to do our cross multiplication. That's going to give us 1/5 x. And that 1/5 times x is going to be equal to 1/15 times 1. Well, 1/15 times 1, of course, anything times 1 is itself, so 1/15. Then we want to get x all by itself. We're using our inverse operations. We're multiplying now, so we need to divide by 1/5. 1/5 divided by 1/5 is just 1, leaving us with x. To keep it balanced, we have to divide this side by 1/5. That leaves us with 1/15 divided by 1/5. And again, we keep, change, flip. So we'll keep the 1/15, keep that. We'll change our division sign to multiplication, and then we'll flip our second fraction. So that'll give us 5/1, which leaves us with 5/15. Now, once again, we know that we can simplify this because 5 divided by 5 is equal to 1. 15 divided by 5 is equal to 3. And 1/3. X is equal to 1/3. Okay? So x is equal to 1/3. If it takes Michael 1/15 of a minute to, well, rather, if Michael can play 1/5 of a song in 1/15 of a minute, that means that if he wants to play one song, then it will take him 1/3 of a minute. Now, it's not really a unit rate until we flip it over, so let's flip it over and say 1/3 of a minute per one song. And there we have it. That is the answer to our question, and that is exactly how we solve our proportions using fractions over fractions. And again, anytime we see a fraction over a fraction, if this is, say, 2/3 over 1/2, just like this is 1/5 over 1/15, anytime we have those, that's called a complex fraction. Complex fractions are fractions divided by other fractions. 2/3 divided by 1/12.